Hello, welcome to 7-Eleven. How can I help you? Can I interest you in our signature Big Gulp? We've got sparkling water, vitamin water, blood orange, craft lemonade, power berry. Oh, you said the only thing you're interested in taking a big gulp of is polynomial word problems? Well, I'm afraid we're all out of that flavor at the moment. So sorry. Have a nice day. Goodbye. Just kidding, I could never be so cruel as to deprive you of your heart's deepest, truest desire to take what we've learned about polynomials and use it to solve some word problems. That's right, it's word problem time, class 7-11. Let's talk problem solving with polynomials, part 1. But before we do, you may recall that when we talked about word problems last, back in Unit 5, and in fact every time before that, we came up with a 5-step checklist of potential best practice to help guide us through the process. Take a look back at those notes, give me 30 seconds. What are some of those things that we might want to keep in mind as we're solving a word or quote-unquote world problem? Go! 5, 4, 3, 2, 1, and stop. Let's dust off those cobwebs. Well, if I have a problem with a visual dimension, it may be powerful for me to draw some kind of diagram to help me keep track of the relationship between those pieces of information. From there, I definitely need to know what I'm solving for, so defining a variable or variables to stand in for the unknown or unknowns in my problem is going to be necessary. From there, maybe, maybe not, but there could be some kind of formula that I want to use to my advantage. In that case, some kind of chart or graphic organizer might be useful. From there, I definitely need to know what it is that I'm solving, so I need to build, in this case, a polynomial equation. That's what we've been building towards this unit. That should probably do the trick for me. And last but not least, I just want to make sure in context, does my answer make sense? Maybe that includes units. Maybe that includes plugging my answers back in to check. Maybe that includes some logic, like did I end up with a negative number for length or distance or time? All that jazz to make sure in context, did I end up with an answer or answers that are reasonable? Cool! With that idea in mind, we've been letting our algebraic representation muscles atrophy a little bit over the past couple of units. Let's see if we can work them out a bit with a problem like this guy. The sum of a number and its square is 72. I want to know what my number is. Now I'll give you a hint. No diagram or chart needed here, but I do want to give myself a variable. I also want to see if I can translate the words in my problem into symbols in the form of an equation that I can solve. Give yourself 2 minutes, at least see if you can get to the equation, and if you're feeling real bold, why don't you try and solve that equation and see if we can get a solution or solutions to our problem. Go! All right, let's do it. So first of all, I need a variable. The thing that I'm looking for, my unknown, is some number. Now, I can call this number anything that I want. I'm going to choose to call it n for number. Now, I'm going to take everything else that's left over and do some translation. Well, let me look for some nice math vocabulary here. The first thing that I see reading from left to right is the sum of. Now, sum always tells me that I'm doing some addition. And what is it that I'm adding here? Well, I'm adding my number, which we called n, and the square of my number, well, that would be n squared. And I know when I sum them, that is, which in other words gives me my nice little translation to equals 72. And would you look at that? N plus n squared equals 72. That's a polynomial equation that I should know how to solve. Now, quickly remind me, how do I solve an equation like this? What's my strategy going to be? 5, 4, 3, 2, 1, 0! And stop. Emphasis on 0 because I need to use the 0 property, which means I need a 0 on one side. If I can factor the other side, then I can set each factor to 0 individually. Now, if a 0 on one side is my goal, the easiest move to make would be to subtract 72 from both sides. But if I'm thinking strategically, well, 72 minus 72 is 0, that's great. But on the left, I need to factor. Remember, factoring is usually easiest in standard form. So I hope you don't mind if I take this n and n squared, because addition is commutative. I'm going to put the n squared before the n, so I'm in standard form, tack that negative 72 onto the back. There we go, we've got a nice standard form polynomial. And this polynomial is what kind of polynomial? Well, it's got 3 terms, its degree is 2. This is a quadratic trinomial, and I know how every quadratic trinomial factors. Well, it's going to be the product of 2 linear binomials. At the front, if I were to met wet back out, right, I know that it needs to be n times n to get me to n squared, so it's got to be n and n at the front. At the back, because my leading coefficient is invisible positive 1, I need 2 numbers at the backs of my factors that will multiply to get negative 72 and add to that invisible plus 1 as my middle coefficient. Well, 2 numbers that do the trick for me would be positive 9 and negative 8. 9 times negative 8 is negative 72. 9 plus negative 8 gives me positive 1. So n plus 9 and n minus 8 should be my 2 factors. From here, I'm home free. All I need to do is do some zero property to split this guy up. The zero property says if n plus 9 times n minus 8 equals 0, then either the n plus 9 is the 0 or the n minus 8 is the 0. All I got to do now is isolate n. On the left, let me subtract 9 from both sides. This tells me that n could be equal to negative 9. Or in my other case, if I add 8 to both sides to isolate n, here my second value of n would be positive 8. Cool! With this idea in mind, let's try 2 more. One by one, here's your first. The square of a number. Is 18 more than 3 times the number? I want to know what that number is. Once again, let's define our variable, see if we can set up and solve some equation by doing some strategic translating. Go, go! Five, four, three, two, one. Let's do it together. All right, first move, I don't need a diagram, I don't need a chart, but I do need a variable. I need some number that I'm solving for. Let me call that number n. Of course, I can use any variable that I want, but it's my word problem. I made the video. I'm calling it n, and you can't stop me. Let's do some translation. The square of my number, so my number is n, its square would be n squared, is here, there's my equal sign, 18 more than. So if I'm more than, that means that I'm adding 18 to whatever that thing is. The thing that I'm adding 18 to is 3 times my number. Well, my number is n. 3 times n would be 3n. N squared equals 3n plus 18. There is my equation. Lovely. All I've got to do now is solve it, and in order to do that, I want to use the zero property. Now, you may remember strategically, it could be easiest to subtract n squared from both sides, but it's often wisest if the square term has a positive leading coefficient. So I'm actually going to leave n squared over on the left because it's already positive. So even though it might seem kind of weird to make this choice, it is going to make my life easier knowing that my end goal is to factor if I move everything else over to the left. So I've got n squared minus 3n minus 18 in standard form equals 0. Once again, this guy is a quadratic trinomial, so let me set up my parentheses. I know that this is the product of 2 linear binomials. At the front, n squared can only come from n times n. At the back, because my leading coefficient is invisible positive 1, I need 2 numbers that multiply to negative 18 and add to negative 3. Well, negative 6 times positive 3 gets me negative 18. Negative 6 plus 3 gets me negative 3. There's my factored form. Beautiful! From here, all I got to do is some zero property. If these two things multiply together to get 0, one of them must be 0. So either the n minus 6 is my 0, or the n plus 3 is my 0. From here, all I got to do is get n by itself. On the left, let me add 6 to both sides. My first possible value of n could be positive 6. And on the right, if I subtract 3 from both sides, that will reveal that the second possible value of n would be negative 3. Very nice. Uno más. Twice a number's square is 3 times as large as the number 3 more than it. I want to know what my number is. Give me a variable, do some translation, give me an equation. And if you're feeling bold, go ahead and solve it. Go ahead. And stop. Once again, I need a number. I'm going to call that number n. You can call it z, you can call it k, you can call it w. I don't care. I'm going to call it n. From here, let's do some translation. I have twice the square of my number. Well, my number is n. Its square is n squared. And then twice that would be 2 times n squared. So 2n squared is on the left. There's my equal sign. I'm 3 times as large as something, so this is going to be 3 times something. Let me represent that multiplication with parentheses. I'm 3 times as large as the number 3 more than it, which is 3 more than my number. My number is n. Well, the number 3 more than n would be n plus 3. Here we go. Here is our equation. Nice. Now, once again, thinking strategically, the 2 in front of the n squared is already positive. It is wisest for me to leave this on the left. So I need to move the stuff on the right over, but this looks a little bit different than the way that I usually like. If my goal is to factor, I want to start by getting rid of these parentheses. So my first move before I move everything over, let's do a little distributive property. So I've got 2n squared is equal to 3n plus 9. And now, once again, I can subtract the 3n and the 9 from both sides. On the right, both of these cancel out. That leaves me with the 0 I desire. And on the left, in standard form, there's 2n squared minus 3n minus 9. Once again, this is a quadratic trinomial, so I'm going to set up my 2 parentheses. At the front, 2n squared has got to be 2n times n. Notice because the leading coefficient is 2, I cannot rely on the fact that they will add to the negative 3. I need to do a little trial and error. So at the back, let me list some options for the 9. It could be 1 times 9. It could be 3 times 3. I know that I want a negative 3. Notice 2 times 3 is 6. 6 minus 3 will get me a 3. So the 3 and the 3 are actually going to do the trick if I make the first 3 positive and the last 3 negative. If you don't believe me, let's do a little bit of a check. So to check my work here to make sure my factored form is correct, don't need to check the first and last. I'm just going to check the outer and the inner to confirm my middle term. 2n times negative 3 is negative 6n. 3 times n is 3n. Negative 6 plus 3 is negative 3n. Would you look at that? There's a beautiful factored form. Cool! Now that I've got my factors, all I need to do is split her up using the 0 property. So by the 0 property, if these two things multiply to get 0, one of them must be 0. So if 2n plus 3 is my 0, I can start by subtracting 3 from both sides. Here 2n would be equal to negative 3. Dividing both sides by 2 reveals that my first possible value of n is negative 3 halves. In my second option, if n minus 3 is equal to 0, adding 3 to both sides here, my second option for n, it could be positive 3. Beautiful. So now that we've done some abstract problem solving, let's get a little bit more grounded, maybe even a little bit more visual with a problem like this guy. I've got a rectangle. Its dimensions are x plus 2 units by x plus 3 units. And I know that its area is 56 square units. I want to find the value of x. Now, there's a piece of information that I do need to know in order to solve this problem. Think creatively. Given what you're given, what do you think you need to use to your advantage to be able to set up and solve an equation here? Take a risk, take a chance, take 30 seconds. Can you figure out what's going to do the trick? Go! And stop. If you guessed that it has something to do with area, then you might be right. Well, I've got a rectangle, and if I want to use its area, I need to know how to find area. Well, you may remember that to find the area of a rectangle, I multiply its length by its width. And with this formula, here's my linchpin. I've in fact got everything that I need. I'm told the area is 56 square units, so I can substitute that in for my area. And I know if I multiply the length and the width, it doesn't really matter which one is which because, of course, multiplication is commutative, but multiplying the x plus 2 by the x plus 3 should get me that area of 56. Look at that. Here's my equation. Nice. Now I need to use the zero property to solve. If you haven't already, take 20 seconds. Pause the video. 20 seconds. Take 2 minutes. Pause the video. See if you can get an answer or potentially answers. If you have already solved it, go ahead and watch with me. First move, just like above. I don't like parentheses yet. If I want to factor, I need a 0 on one side first. So let me start by doing a little metwet. First of all, x times x gives me x squared. X times 3 gives me 3x. 2 times x gives me 2x. And 2 times 3 at the back gives me plus 6. All of that is equal, of course, to 56. Last move, let me add those middle terms together here. 56 is going to be equal to x squared plus 5x plus 6. From here, I want to use the zero property. Easiest way to do that would be to subtract 56 from both sides to get a 0 on the left. So here 0 is going to be equal to x squared plus 5x minus 50. Once again, quadratic trinomial. I'm going to set up my two parentheses, thinking smarter, not harder. At the front, x squared can only come from x times x, so it's going to be x and x at the front of my factors. At the back, because my invisible 1 is at the front of my polynomial, I need two numbers that multiply to negative 50 and add to positive 5. Well, it turns out that 10 times negative 5 is equal to negative 50. 10 minus 5 is equal to 5. All I got to do now that I've got my factored form is some zero property. So either the x plus 10 is my 0 or the x minus 5 is my 0. If x plus 10 is 0, subtracting 10 from both sides, here x is equal to negative 10. If x minus 5 is my 0, add 5 to both sides. Here x is equal to 5, and I'm done. What do you mean? I said, and I'm done. I might not quite be done yet. What do you think is missing here? There's a little bit of a problem with my answers. Think strategically, think creatively, think in context. What's wonky here about these solutions that I've identified? 20 seconds, go. Alrighty. Well, first of all, I hope you noticed that I didn't include units. I wasn't told what they were. Maybe they're feet, maybe they're meters, maybe they're Mr. Villels, I don't know. But either way, it's negative 10 units and 5 units. But there's an even bigger issue. If I choose x to be 5, 5 plus 2 is 7, 5 plus 3 is 8. A 7 by 8 rectangle makes sense. But if I choose negative 10 and plug back in, that says the length and width of my rectangle are negative 8 and negative 7. But I can't have negative lengths. So in the context of this problem, negative 10 can't possibly be an answer. 5 is the only one of these that makes sense. Magnificent. So we're done for today, but let me give you a preview of what's to come. Now that we've done some abstract problem solving, we want to get a little bit real with it. So take, for example, this problem. Read it to yourself. I'm not going to read it, even though it's funny. It is, in fact, a real statistic, actually. It's in the Guinness Book of World Records. But this will be what we open up with together next time that we see each other. If you're feeling bold, if you're feeling brave, if you're craving a challenge, give yourself a little bit of time. See if you can find the answer/answers to this problem. But until then, take care, be good, sleep well, don't die. Goodbye.